All right, hi guys. So today we're going to go over the third way to calculate enthalpy, which is Hess's law. I really like Hess's law because it's kind of like a puzzle. And so if you like puzzles, you'll probably like Hess's law. You'll definitely want a calculator today. That's probably pretty much it. All right, so let's get started. So Hess's law basically says that the change in enthalpy is the same whether the reaction occurs in one step or several steps. So our change in enthalpy is not dependent on the reaction pathway. And we can actually figure out our change in enthalpy because it is the sum of delta H for each step is going to equal our total change in enthalpy. So basically what we're going to do is we're going to look at our reaction pathway and we're going to manipulate our equations so that they add up to our total overall equation. Once they do that, we'll add all of our changes in enthalpy together and make it happen. Sometimes when you're manipulating, you are going to have to do several different things. So like if you reverse your reaction, you're going to reverse the delta H sign or, change it to negative or positive. So like if it is negative, you reverse your reaction, it's going to become positive. If you multiply your equation by something, so if I multiply my whole equation by 2, I also have to multiply my delta H. So basically whatever I do to my reaction, I also have to do to my change in enthalpy as well. Okay, so let's get started. So given the following reactions and the respective enthalpy changes, calculate delta H for the reaction. 2C plus H2 yields C2H2. Okay, so first thing that we're going to do is we just kind of need to find where are these things in my reaction. So like C2H2, there it is right there. There's carbon, there's hydrogen. All right, so now let's look at where they are like in my overall reaction. So I can see that right now C2H2 is a reactant, but in my overall reaction, it's a product. So I'm probably going to need to flip this reaction, which means I also am going to flip my delta H. All right, since it's a product. All right, my H2 looks pretty good, but my C, I have 2 C's here. I only have 1 here, so that means I'm going to multiply this reaction by 2, which also means I'll need to multiply my delta H by 2 as well. Okay. So let's go ahead and do these changes. I like to write out the changes after I've done them and then cancel out. So since I flipped this first reaction, when I flip it, it'll be 2CO2 plus H2O yields C2H2 plus 5/2 O2. And then my delta H would be positive 1,299.6 kilojoules per mole. All right, and I multiply that one by 2. I would get 2C plus 2O2 yields 2CO2. I multiplied that by 2, so I need to multiply my delta H by 2. So negative 393.5 times 2 would give us negative 787 kilojoules per mole. And then our last one, we just left it as it was. So we had H2 plus 1/2 O2 yields H2O. All right, and our delta H doesn't change because we left it exactly the same. Of course, if you write it wrong. All right. Okay, so now what we're going to do is we're going to cancel out what's on both sides and make sure we're left with just our overall reaction that we had. So start here. We have CO2 on my reactant side. It's also on my product side, so that is going to cancel out. I have H2O on my reactant side, and I have it on my product side, so that'll cancel out. I have C2H2. It's nowhere else, so that will stay alone. 5/2 O2. I have 2 O2. That's basically 2.5, right? 2 O2 here, 1/2 O2 here, so those will all cancel out. I don't have carbon anywhere else. I don't have a hydrogen anywhere else, so I can kind of write out my equation. I'll get 2 carbon plus hydrogen yields C2H2. That does match our overall equation, so it looks like we're good to go. So I can just add up all of my delta H's together to get what the delta H of reaction is now that I've manipulated it. So 1,299.6 plus negative 787 plus negative 285.9. Plug it all into your calculator. I'm going to give you guys a minute to do that. And once you do, I got that our delta H would be 226.7 kilojoules per mole. There you go. That is how you would do Hess's law. Okay, let's do one more together. And then after we do this one, we will do, I'm going to leave one for you guys to do on your own as well. Okay, so this one is a little different because it doesn't actually give us the reactions. We have to write them based on information from the equation. So this first says the heat of combustion from C to CO2 is negative 393.5 kilojoules per mole of CO2, whereas the combustion of carbon monoxide to CO2 is negative 83.0 kilojoules per mole of CO2. Calculate the heat of combustion from C to CO. Okay, so first off, we need to figure out what overall reaction we're looking for. And our overall reaction we're looking for is the combustion of carbon to carbon monoxide. So let's write that equation. So if I have carbon and I'm combusting it, that means it's reacting with oxygen. So carbon plus oxygen should yield CO. That's our overall reaction we're looking for. Obviously, it's going to be, to balance it, I would just put a half in front of that O2 there. You could also say like 2 carbons, 2 carbon monoxides if you want to as well. But I just think using the half is a little easier sometimes. Okay, so now let's look at the baby equations we have. So we have the heat of combustion from carbon to carbon dioxide. So let's write that one out. So carbon plus oxygen yields CO2, and the delta H value there is going to be 393.5 kilojoules per mole. And then we have combustion from carbon monoxide to carbon dioxide is negative 83.0 kilojoules per mole. So combustion of carbon monoxide would be carbon monoxide plus oxygen yields CO2 again. And our balance this one, if you put a half in front of the O2 again, it'll also balance this equation. And our delta H here is negative 83.0 kilojoules per mole. Okay, so now we need to figure out how we're going to manipulate these equations to get what we want. So we want CO as a product, so that means we definitely need to flip this reaction. Other than that, I don't see anything else we need to do. So let's flip that reaction and see what we have. See what we've got. So C plus O2 yields CO2. Delta H is negative 393.5 kilojoules per mole. And then if I flip that other one, I get CO2 yields CO plus 1/2 O2. Delta H, since it's flipped, would be 83.0 kilojoules per mole. All right, so I have CO2 on both sides, so that will cancel out. I have half O2 and O2, so this half is going to cancel out, and that's going to go down to a half. So then when I add it together, I get C plus 1/2 O2 yields CO. Add your delta H's together. That does match, this one does match my overall reaction, so we're good to go. We did it right. So if I add my delta H's together, I get that the combustion of carbon to carbon monoxide would release 310.5 kilojoules per mole. We're just adding them together, our delta H's together at the end, after we've manipulated our equation. All right, guys, I want you to go ahead and pause the video and try this last one. You have your overall reaction up here. You have your stepwise reactions down there. See how you can manipulate them to solve for the overall delta H. Okay, hopefully that was enough time for you to work it. So I looked at our overall reaction. NH3 plus HCl yields NH4Cl. Found that I had in our first equation, we have the HCl there, but we have 2 HCl. So to get that down to the one that's in our reaction, there's no HCl anywhere else. I multiplied it by a half. The next one we found was NH4Cl. This reaction didn't really seem like it needed anything to change. The coefficient was right on the NH4Cl, and it was on the right side of the reaction. So that one was good. And then our NH3, that one we did have an issue with. It's on the product side, and the coefficient's too big. So I flipped it and multiplied it by half. So I have my reactions here that I have manipulated. So let's go ahead and make sure everything cancels out. So over here, if I'm looking at my first reaction, I have 1/2 H2 on this side. Well, I have 2 H2 on this side, but I also have 3/2 H2 down here. So 1/2 and 3/2 would be 2. So all of those hydrogens are going to cancel out. 1/2 Cl, 1/2 Cl, those will cancel out. 1/2 N2, 1/2 N2 will cancel out. So I'm left with my overall reaction being HCl, let me try again, plus NH3 yields NH4Cl. So then I can just add up all my delta H's. After I've manipulated it, I was going to write delta HCl. I don't know where that came from, guys. I'm losing it. And I get the delta H of my overall reaction would be negative 314.4 kilojoules. And that is how you do Hess's law. Hopefully you feel pretty good about it. We'll definitely post some practice for you guys to complete over Hess's law with the rest of this class period. All right. I hope you guys have a great day. Bye.